Alright, I've written a quadratic equation on right here on this piece of paper. Now, this looks like it would be solved using what? Easy method. Very good. Easy method. This is a quadratic because it's in the form ax squared plus bx plus c, where c is 2, b is 3, and a is 1. A, B, C. 1, 3, 2. Now, what if I told you that instead of factoring this quadratic by the easy method, that we could graph it and get the same exact answers? Okay, so what I gave you today, this packet, teaches us how to graph these functions and get the same answer. So our learning target is I can find solutions or factors. So like we've been factoring thing, we can find factors of a quadratic function using its graph. Stop writing on my desk. Okay, so let's review some of these definitions that we've been going over the past 2 days. Quadratic function is in the form ax squared plus bx plus c. So it has to be in that form. Okay, a parabola is the shape of a quadratic equations graph. So a parabola is the shape that our I did not spell that right. I was thinking ahead to equation. A parabola is the shape of a quadratic equations graph. Quadratic equations graph. Okay, our vertex is going to be the highest or lowest point. Highest or lowest point. What's the highest point called? Maximum. What's the lowest point called? Minimum. Good. So, if I were to just sketch this, what kind of graph would this be? Minimum, because here's your vertex at the very bottom. That's a minimum. If I were to sketch it over here, when you're drawing a parabola, it's really just like drawing either a U or an N. In this case, it's a U. If I'm drawing one with a max, then it looks like an N, where your vertex is way up here, and it's a max. Okay, our solutions, aka roots, are found when they cross the x-axis. This thing right here. Wherever it crosses this is a root. So in this case, we have 2 roots. In both of these cases, we have how many roots? 2. Because it crosses this axis twice. Okay, we've been calling them roots, which is what I'm going to continue to call them. But there are 3 names for solutions, or your roots. So they are known by roots. What's another word? Yes, very good. Zeros and x-intercepts. X-intercepts. Okay? So that was just a review, right? Nothing new. Okay, solutions to a quadratic function can have 2, 1, or no solutions. So we can either have 2 solutions, 1 solution, or nada solutions. This graph right here, let's draw an example of two solutions. Okay? It's where it's going to cross this x-axis right here. Has to cross it twice to have two solutions. So I'm going to put a dot on 1 and 7 and then draw my parabola through those points. That's an example of two solutions.
1 and 7 and where?
Just 1 and 7 and just guess the rest of it. Okay, it's just a sketch. So right here, my solutions for this graph are 1 and 7. Okay, example of one solution. Put a dot at -6. And then make that be your vertex. So draw parabola going up. That's an example of one solution. It only touches or crosses the x-axis one time. So my solution is x is equal to what? -6. So an example of no solutions looks like this. Something that's up there, down here, whatever. Doesn't touch it at all. So you have no solution. All right. Good job so far. So y'all know I like steps, and you know I like my little, these are called anchor charts. I love anchor charts. So I've made you one that's on the front board. This tells you every step to take to graph one of these quadratics, okay? Because in the next 15 minutes, we're only going to get through 2 examples.
Is it really that hard?
It's not hard. It's just tedious and long.
What's tedious?
You have to be very careful.
Cautious.
Cautious. All right, so first step. First step. Colby, read my first step, please.
Identify A, B, C.
Identify A, B, C. And I put the standard form of quadratic up there, so you always remember what A, B, and C is. So looking at example number 1, A is 1.
B.
Not 2. B is -2. And C is what? -3. Good job. Step 1. We identified A, B, and C. Step 2 is what, Vanessa? Find your vertex. Now, you have to find your vertex because after these examples, these numbers right here will not be given to you. And you have to figure out what numbers to use because if you don't have to flip, but these numbers go from -5 to 1. Whereas our examples today go from -3 to 3. So when you find your vertex, that tells you where to start. So that formula gives you your vertex. So you can write, look, so some of you are like to be very cautious and like to have your correct spacing. Do not write below this line. Okay? Do not write below that line. Because we're going to use all that space below it. So to find your vertex, we have to use the formula -b divided by 2a. -b divided by 2a. So, when we take our a, b, and c to plug into this formula, leave your negative from your formula. So we have -b from your formula. But what is b? So we have to keep our negative and then write -2. Which it does. I'm just making sure you see how I get there. Which goes to +2. You're correct. I just want you to see that. Negative times negative is a positive. And then 2 down here. 2 times a. Well, our a is 1. So 2 times 1 is 2. And 2 divided by 2 is. So this is my vertex. So if I had to make my own chart, I would need to write my vertex and then 2 to 3 numbers above and 2 to 3 numbers below. If we were making our own chart. Because we aren't, and this is what they gave us, it's okay. Alright, so now we know all of our x's, we know where to start, but we need to find the y's. Any guesses on how to find these y's? You have, not y equals mx plus b. You have to plug all of these x's into the spot of the x right here. And when you solve the whole thing, you'll know why. So start with -3. Instead of writing x, we have to write whatever number this is. So you would write -3 squared minus 2 times what? Times -3 minus 3. Here's where you have to be very careful. This is not -3 times 2. This is -3 squared. And -3 times -3 is positive 9. -2 times -3 is positive 6. And then minus 3. 9 plus 6 is minus 3. So your y is 12. What I need you to do is I need you to finish finding the y for all 6 of these. Okay? Work together, but plug. So now I'm not plugging in -3, I'm plugging in -2. So -2 squared minus 2. Not -3, but -2. And then this minus 3 is part of the equation. So minus 3. And then finish solving for your y's. Someone asked me if they can plug it all into their calculator and just press enter. Yes. But you have to make sure that you're plugging in the squared correctly. -2. Okay, make sure you put, see how I put a negative in parentheses. Because if you just put -2 squared, it gives you -4, and that's not right. Yep. Makes a parabola. It's okay. It's going to go off a little bit. It's okay. Yes, that's fine. That's good. But you can use that on a test. You can learn how to use it on calculator. Yep. So once you're done finding all those things, that table tells you all the points to plot. So those will tell you how to graph your parabola. Okay. You make it 3. But negative 2 times 0 is 0. Well, go ahead and plot all your points.
Wait, did you put all of these ones?
Yep. So you'll plot here. These are each 1 point. Negative 312 is 1 point. Good, plot your graph.
There isn't a 12 though.
It's okay. You can go up a little bit. Okay, so can I show you something? So you plotted all your points correctly. This is your axis of symmetry, right? So you kind of guess for these two, all right? Okay. Your axis of symmetry. They have to be even on both sides. So if you wanted to finish it off, because that drives you crazy and it only 2, know that this one has to be 3 away from the axis of symmetry. This one right here has to be not from your axis right here, from your axis of symmetry. So it has to be the same distance away. Yes. The 1 1. Okay, if you plug it in, 1 squared minus 2 times 1 minus 3. Well, that's 1 minus 2 minus 3. 1. Did I do that wrong? 1 minus 1 minus 2 minus 3. That's 4. Good. See, this isn't hard. It's just takes a lot. Alright guys, so most of you are wrapping up number 1. So to check your answers, you should have negative 312, negative 2, 5, 0, negative 3, negative 4, negative 3, 0. Okay, so even if you don't, go ahead and write those down so we can graph these. Each one of these is a point. So this is 1 point on your graph. This is 2 points. Your vertex is this one. Okay, so if I were to plot all of these, I would go over negative 3, up 12, but oh wait, there's not a 12. It's okay. Just go up a little bit. 2, this one? 2 squared minus 2 times 2 minus 3. So we get 4 minus 4 minus 3. 4 minus 4 is 0. Minus 3 is negative 3. Alright, so I'm going to plot all these points. Hey, can I ask you a question? Thank you. How many of you, it drives you crazy because this side is perfect and you know which points to take and you don't know how to take this one? Yeah. Okay, well, remember that thing called axis of symmetry? Axis of symmetry is wherever the vertex is, right? So this is your axis of symmetry. Well, this is your vertex, And this point right here is 1 away from your axis of symmetry, and so is this one. They're equal distance away. This one's 2 away. Well, this one is 2 away. So this one is how many away from the axis of symmetry? Which means on the other side, this one will be 3 away. This one is 1, 2, 3, 4 away, which means if I want to even it out, it would be over here on this side. So to draw your parabola pretty, you would follow these points. You don't have to. Okay, so now, how many solutions do we have? 2, because it crosses the x-axis twice. So one of them is at -1, right? And the other one is at what? 3. And your vertex, you can look right here, or you can know that we already know this is the vertex. So 1, -4, and you're right, it is a minimum. Good job. Okay, what I want you to try to do right now, and before you come back tomorrow, just finish the next one. Finish number 2. Remember, first step, label A, B, C. Then find the vertex. So you have A is 1, B is -4, C is 4. Find your vertex with the formula -b divided by 2a. Okay, try that.